This is a continuation of the video that I made starting worksheet 5. As a review from worksheet 5, we found the force of gravity on this satellite as it's in orbit far above Mars. In this case, it's 700,000 meters above the surface of the Earth. So the total orbit of Mars was 4,089,500 meters. We found that the force of gravity was 1,020 when it was on the surface of Mars, and it had gone down to 764 by using this new equation here. So what we've done here is we've found how big the force of gravity is as this satellite is in orbit. Well, the satellite is moving in a circle, right? And a thing only moves in a circle if there's a force pointing toward the center of that circle while it moves around and around. That means that this force of gravity is the same as the central net force. So the central net force is 765 newtons. I'm just going to round it to make it easier. Okay, the next question, here's what I'm going to do. I'm going to redraw that picture. So here we have Mars. Here we have the satellite. And the satellite is going into orbit. There's a force of gravity pointing inward, and then the satellite gets to different spots, and the force of gravity is always, wherever it is, pointing inwards. Well, that force of gravity is the central net force. And we know that that value is 765 newtons. Okay, so that's equal to m times v squared all over r. Okay, if you remember from before, the mass of the satellite was 300 kilograms. So we have 765 newtons is equal to 300 kilograms times, we don't know how fast it's going around, so we're going to leave that as v. Keep it as v squared all over r, and that radius was what I said earlier of 4,089,500. From here, from the fact that the force of gravity is the central net force, we can calculate for the velocity. I need to multiply by 4,089,500 and then divide by 300. So I'm going to do just that. You can see 765 times 4,089,500 divided by 300. V squared is equal to 10428,225. Whoa, that's a big number. I'm not done yet. I have to take the square root of that. So the velocity in this case will be 3,229.2. 3,229 meters per second. There's our final solution. And finally, you might be asked how to find how much time it takes to go around in this full circle. So as it's moving, the speed is 3,229 meters per second, but we might want to figure out how much time it'll take to go all the way around. Well, if you remember, speed or velocity is just distance over time. We're looking for the time. That's what we don't know. We now know the velocity. That's what we do know. So the other thing that we better know is we better know the distance. Well, the shape that it's going around is a circle. So that distance is actually the circumference. I'm going to find the circumference here. It's equal to 2 times pi times r. So I'll do 2 times 4,089,500 times pi. And I get that the circumference, or the distance, is equal to 2,569,5086.31 meters. that's the distance that I'm going to put here. So I'll say 3,229, which is the velocity, is equal to that value that I just got for the circumference divided by the time. And now I have to solve for the time. Multiply both sides by time. Divide by 3,229. So the time will be equal to 7,957 seconds. Oh, I'm going to round it. 958 seconds. That's a long time, but that's not too much time. I might you don't have to do this, but I'm going to convert that into minutes by dividing by 60. That's 132 minutes, 132.6 minutes. And if I divide that by 60 again, I'm going to convert it into hours. That's about 2 hours. And it'll be 2 hours and 12 minutes about. So the satellite that orbits around Mars, when it's this far away from Mars, when it's 700,000 meters away from the surface of Mars, this distance here takes about 2 hours to go all the way around. The work that we've done here is a culmination of everything in the unit. So I know that worksheet 5 was a difficult worksheet to finish. I hope that this video is helpful in making that happen. And what I want to summarize is the first thing that you're doing that's new is finding the force of gravity using this equation here. Then you set that force of gravity equal to the central net force. Then the rest of the work is review from what we had been doing earlier in the unit. The central net force is 765, so you can find the speed. And if you know the speed, then you can find how much time it will take to go in the circle. Good luck. I hope that you can make corrections to all of the worksheets. And let me know if you have any questions. Thank you.